Alright, first problem on the study guide. When the piggy bank was opened, it yielded $1.35 in nickels and pennies. So it tells us we have nickels and pennies, or our coins, how much money we have. So if we start off with just that much information, nickels, pennies. Coin problems, we want to have number of coins and value of coins. And typically with coins, we want to do value in cents. We'll say we have N nickels and P pennies. Every nickel's worth 5 cents. We have N of them. Every penny's worth 1 penny, 1 cent, and we have P of them, so 1 times P. You can just as easily put P for the value of the pennies. So if I have 5 pennies, I have 5 cents, 10 pennies, 10 cents. P would work. If we go with the value fact, it says we have $1.35. $1.35 is equivalent to 135 cents. So if I'm looking at using the value variables in the same unit, I want to make sure my value is in the same unit. And so we're going to go with 5n plus 1p is equal to 135. The second fact, it says there were 55 coins in all. So altogether 55 coins. The number of coins is based on the number of nickels and pennies we have. So the number of nickels plus the number of pennies equals the number of coins. Just like that, we get ourselves a system of equations, and 5n, n, p, p, 135, 55. So letter plus letter equals number. The structure is better for elimination and substitution. This is p, so changing the signs in the bottom equation would be sufficient. I could just easily change the signs in the top equation. The p's are going to cancel for elimination, so 5n minus n is 4n. P minus p cancels, 135 minus 55 is 80. We divide both sides by 4, we get n equals 20, and that's 20 nickels. The question asks how many were nickels, how many were pennies, so we got the number of nickels. If I go back to the fact there's 55 coins, and 20 of them are nickels, that means the other 35 would have to be pennies, so p is equal to 35 pennies. Okay, so expect it to be a coin problem. I'll give you the value, I'll give you the number of coins, so the structure of the system should be like this, and you should expect to get whole number answers. Number 2, Ramses thought of 3 consecutive even integers. So consecutive integers, if I see that, and I see the word even integers go up at a +2 pattern. So that establishes for me that the 3 consecutive even integers should be n plus 2, and n plus 4. The first integer we're establishing is an even number, and then the next even number is 2 bigger and then 4 bigger. If it's a consecutive odd integers, it's still a +2 pattern. The first number is odd, add 2 to get the next odd, add 4 to get the next odd. So whether it's even or odd, but it'll probably be even since it's displayed on the study guide. He found that 3 times the first integer, so 3 times the first integer is n, so 3 times n was equals 2 more than, we ignore more than, less than statements till the end, and then it says the sum of the second and third integers. So the sum of these 2 integers, which means add those up. And again, if we go back to the was 2 more than happens after the word us, so after the equal sign, so we're going to put a +2 on the right hand side to fix it. So that's our first priority, is to write an equation. After we set up our unknowns, we go ahead and solve the equation, combining all the like terms on the right hand side. 3n equals 2n plus 8. If I move the 2n over there, subtract it, I end up with 3n minus 2n, which makes 1n, and what's left on the right hand side is 8. 8 is representing n, which is the first integer. We're supposed to find all 3 integers. What were the integers in the 3 consecutive integers? So 8, 10, and 12 is what I'm going to go with. So again, you're going to find this answer, but you still have to create all 3 based on that pattern. Number 3, 2 dice are rolled. What's the probability the sum of the numbers rolled is 4? Now we made this chart each time for this problem. I'm going to give you another way of looking at this that you might prefer. The outcome possibility for rolling 2 dice starts at 2. If you roll 1, 1, that's 2. And then it works its way out to 3, then 4, then 5, then 6, then 7, 8, 9, 10, 11, and 12. Those are all the outcome possibilities rolling 2 dice. And there's exactly one way to make 2, one more way to make 3, one more way to make 4, one more way to make 5, one more way to make 6, one more way to make 7, and then it starts decreasing after 7 back down. 5, 4, 3, 2, 1. So this is possible ways to do it. You get the same information the chart supplies. There's one way to make 2, there's 2 ways to make 3, there's 3 ways to make 4, and so on. But you don't have to make that whole chart every time. This is a little bit easier to create. And all that we care about with probability is on top, how many ways are there to make what you want to have. So we're trying to roll a 4. So there's 3 ways to make a 4. And what goes on the bottom is how many ways there is to do anything. And we're rolling 2 dice. There's always 36 outcomes. So the possible ways add up to 36. If you try and add those up, 3, 6, 10, 15, 21, 26, 30, 33, 35, 36. So there's 36 ways to do anything. That goes in the bottom. And then, of course, we reduce that fraction. 3 and 36 both reduced by 3, so 1/12 is the answer for that one. So if they had said that what's the probability that the sum of the numbers is less than 6? Less than 6 would be 5, 4, 3, or 2. That adds up to 10, 10 over 36. So again, you can get all the information you need by creating this structure. Just know that it goes up to 7. So 2, 3, 4, 5, 6, 7. That's the most possible. And then it starts decreasing again. 1, 2, 3, 4, 5, 6. Then back down. 5, 4, 3, 2, 1. Is 0, 1, 1, 2, 2, 1, 3, 2 a function? Yes or no? All we have to do with an set of ordered pairs is verify the first numbers are different. If they are, it's immediately a yes. So 0, 1, 2, and 3 are all different. The answer is yes. Just to give you a couple that are not, or a couple things to look for that would be different than that. If I gave you the set of ordered pairs that said, let's say 0, 1, 0, 2, 1, 1, let's say 1, 3. All right. And if I had that one there, 0, 0, 1, 1. So same, 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 same. So as soon as you see same, look and see what they're going to. If they're going to different numbers, the answer is no. So the same number, 0, 0, going to different numbers, 1 and 2, so that's a no. Even if this didn't happen, all right, as long as it happens once, it's no. And the fact that it happens more than once, 1 goes to 1 and 3, that's also a no. But again, 1 no is sufficient. Another situation where that happens, let's say we have 0, 1, 1, 2, 3, 7, 0, 1. And we go with this whole thing, are they different? So 0, 1, 3, 0. So 0, 1, 3, 0, the zeros obviously are the same, but if we take a look, this 0 is leading us to 1, this 0 is also leading us to 1. They're the same point, so that's still a yes. Right, so if they're different, it's immediately a yes. If they're the same and they go to different numbers, it's a no. If they're the same but they go to the same number, it's still a yes. So those are the 3 scenarios that could happen on a problem like that. So just know what makes a yes, what makes a no. Number 5, if f of x equals x squared plus x plus 1, find f of 3. F of 3 simply means to take each x and change it to the number 3, keeping the structure of the problem as it was. So x is being squared, added to x, added to 1. Change all the x's to 3's. Follow the order of operations. 3 squared is 9. And once I did the squaring, all this left is addition. 9 plus 3 plus 1 is 13. So that's all functional value is. Substitute x with the number that's right there. And again, whatever's happening to x is happening to the substitution. Number 6, find the domain and range of the graphed function. Domain is all about x, and it's going to be looking like this. Our job is to fill in these 2 holes, and maybe there's an equals to on these. All right, so if I go ahead, and that's the structure I'm looking for. What I'm looking for is how far left and how far right does it go. So I'm on the x-axis. The graph begins here at this level and ends here at this level. So 1, 2, 3. This is -3. 1, 2, 3. That's +3. So -3 and +3 are what go in that inequality. And then at negative 3 there's a closed circle, so we're going to put an equals to. At positive 3 there's an open circle, so we keep it just less than. These are always less than symbols. Small number, less than x, less than big number, equals to if necessary, and that's how we get the domain. Alright, so everything written there is exactly what the domain should look like. The range is all about the y value, so we're about the y-axis, so it's going to be something is less than y is less than something. And what we're looking for on the y-axis is the lowest and the highest point on the graph. The lowest point happens here, the highest point happens here. This is negative 1, negative 2. This is positive 1, positive 2. So the bottom of the graph is negative 2, the top of the graph is positive 2. At the bottom of the graph there is no circle, which is a closed circle, so there's an equals to. The top of the graph there's a closed circle, so that's also an equals to. Even though there's a hole at 1, there's not a hole at 1 right here, so every value between negative 2 and 2 has been taken in. Closed circle here equals, closed circle there equals. So you don't worry about the between, just worry about the endpoints. And that's it. That's what the domain and range should look like. Domain's about x, range is about y. Smallest, biggest x equals 2 or not. Smallest, biggest y equals 2 or not. And that's what you have to figure out on those. Number 7, find the equation of the line. So the two things I need are the slope and the y-intercept. In order to find the y-intercept, just look. So here's the y-axis, and it crosses right here. The value of that point is negative 1, negative 2. So the y-intercept's value is negative 2. The other thing I have to do is establish the slope. The slope is found by going from a point to another point. This is one point already there. Here's a second point. Here's a third point. Here's a fourth point, fifth point. Take as many points as you want, but all you need is 2 points. I'm going to pick these two. I want to go from the red to the blue, vertically first, in a direction. So I'm going up 1, that's a positive 1 movement. I'm going right 2, that's a positive movement also. Up is a positive movement, right is a positive movement, down is negative, left is negative. So I'm going up and right to get from here to here. Slope is the rise over the run. Rise is the up and down, and run is the left and right. That's all slope is. Positive 1 over positive 2, 1/2. And once you get both of these answers, both of these numbers, the equation of a line structure is y equals mx plus b. M goes right there, and b goes right there. So the answer is y equals 1/2 x minus 2. Number 8, 4x plus 3y equals 17, 3x plus 2y equals 12. Elimination is the best setup for this since the structure is x, y equals number for both equations. I'm going to get rid of y because I can make both of those equal 6 pretty easily. One has to be negative. I'll take the top equation times a positive 2, which will make a positive 6y. That means I have to take the bottom equation times a negative 3 to make a negative 6y. If I do the purple multiplication first on top, I'm going to get 8x plus 6y is equal to 34. Multiplying the bottom equation times negative 3, I'm going to get negative 9x minus 6y equals negative 36. Okay, once I multiply both equations to create these opposite objects, I simply add the two equations together. 8x minus 9x is negative 1x. 6y minus 6y cancels. 34 minus 36 is negative 2. If minus x equals minus 2, positive x equals positive 2. Ordered pair answer 2 comma something. I still need the something, so I go back to one of my equations. I prefer to go back here because the numbers are smaller and all the positives in there. So x equals 2 is what we found for x. I've got an x here and here. I can pick either one, change those x's to 2's to figure out the y value. I'm going to go to the bottom equation. 3 times x plus 2y is equal to 12. Changed x to 2 because that's what x equals. 3 times 2 is 6. It's positive 6, moves across as negative 6. 2y is equal to 6. Divided by 2, y is equal to 3. And there's my ordered pair answer, 2 comma 3. I could have just as easily gone back here. I'm putting it in 2 there. I would have gotten 8 plus 3y is equal to 17. Move the 8 over. I get 3y equals 9. Divide by 3, I get y equals 3. It doesn't matter where I go, I'm going to get the same result for y. So again, once you've found an answer, go back to either equation to find the other answer. Number 9, simplify. We got a bunch of letters raised to powers. The first step of simplification of this type of problem is to focus on that type of structure, a power to a power, and the rule states we're supposed to multiply the powers. So, x is the base, negative 2 times 3 is negative 6. Everything else stays as is. So we get x to the 5th, x to the 0 on top, x to the 4th, I'm going to write x to the 1st, and x to the negative 8th. So job 1, dealt with that, done. Second job, I'm supposed to deal with all the negative powers. So, on 0 power. So negative power, negative power, negative power, right? 0 power, negative power. Those three things have to be dealt with. Everything else stays as is. So, in blue, I'll do all the stuff I've got highlighted here. So x to the negative 6 belongs on the bottom, x to the negative 8 belongs on top, and x to the 0 can just be struck out. Everything else stays right where it was at. So x to the 5th on top, x to the 4th, and x to the 1st on the bottom. Next step, I'm going to multiply the top and the bottom individually by adding powers. So on top, x is the common base, 8 plus 5 is 13. On the bottom, x is the common base, 6 plus 4 plus 1 is 11. I'm adding up all the powers to do that. The final step is division. Division is if the same letter happens on top and bottom, the answer goes where the bigger power is, subtract big minus small to get the answer, x squared over 1, or just x squared is the final answer. So every type of step is necessary, power to a power, negative and 0 powers, multiplication and division. So expect that those are the 4 steps in the process. If I got to this point and there weren't x times x, then I don't do that. So again, if you get to the step and you're supposed to do something that's not happening, just move on. Number 10, we got a main equation on top here, r sub m t sub m equals r sub k t sub k. And then we got some substituting equations down at the bottom. R sub k is equal to something else, r sub m is equal to something else, t sub m is equal to something else. So those three things circled in purple, green, and blue have different versions of themselves. So going back up to the main equation, r sub k has, oops, that should be purple instead of green. Let me try it again. There we go. R sub k has a different version of itself, r sub m has a different version of itself, and t sub m has a different version of itself. So those three things that are underlined are going to be replaced with 8, 6, and 7 minus t sub k, and t sub k is just going to stick around in the expression. So r sub m equals 6. T sub m is equal to 7 minus t sub k. I'm replacing 1 with more than 1, so parentheses, equals r sub k, which equals 8. And t sub k has no replacement values, so I'm going to keep that t sub k. So everything got replaced except for this. And by doing that, the only variable left is t sub k. So now I'm just going to solve this equation using basic technique. Distributive property first. I'm going to get 42 minus 6t sub k equals 8t sub k. Move this over, becomes positive. That gets me 42 is equal to 14t sub k. We divide by 14, t sub k is equal to 3. Once I know what t sub k equals, right there, I can figure out t sub m. T sub m is equal to 7 minus t sub k, and t sub k's value is 3. And 7 minus 3 is equal to 4. Just like that, we get both answers. No ordered pair necessary, they just write it like that. The sub m equals 4, the sub k equals 3. Number 11, solving a rational equation. My advice has always been on these problems, get rid of the fractions. The least common denominator of 4 and 3 is 12. This is not a fraction, so it's over 1. It has no bearing on the common denominator decision. When we multiply, it's 12 times this. All right, we divide first, multiply the result times the top. 12 divided by 4 is 3. We're multiplying 3 times the entire top. So 3 times 3 is 9, and 3 times x is 3x. So be careful if you have multiple pieces. This quotient, whatever it is, 12 divided by 4 is 3. 3 times both things, distributive property. When I do 12 times this fraction, 12 divided by 3 is 4, times negative x is negative 4x. and 12 times 4 is equal to 48. If you got a non-fraction, you just do a straight multiplication there. The equation in black, green, and blue is equivalent to the top equation, but there's no fractions to deal with. What's left to do now is to solve. So if I move the 9 over to the other side, it becomes negative. Combine like terms. 3x minus 4x is negative 1x. 48 minus 9 is 39. Minus x equals 39, so positive x equals negative 39. Number 12, factor completely. It's a trinomial, x cubed plus 15x squared plus 56x. First thing we always look for is greatest common factor, which every term contains the letter x. So if I take an x out, I'm going to be left with x squared for the first, 15x for the first for the second, and plus 56 for the last. Then I'm looking for two numbers that multiply to make 56 that add up to 15. So factors of 56 whose sum is 15, 7 and 8 come to mind right off the bat. So if you can figure those out right off the bat, great. If you can't figure it out right off the bat, 1 times 56, 2 times 28, 3 doesn't go in, 4 times 14. Just kind of work your way up to it and figure it out. But 7 and 8 make 15, and they also make 56 when I multiply, so those are the magic numbers. Parentheses, parentheses. Letter in this is x, so I put x, x. I put plus 7, plus 8, and then the common factor that's part of the factored form up there brings down to the final answer. So looking for that, factoring completely, all the pieces, the greatest common factor times the binomial product that is created by the chart that we use. Number 13, multiply. Multiplication of polynomials just means I have to multiply x times all this stuff, then I have to multiply 2 times all this stuff, and then combine like terms. So, x times this and this and this is 3 multiplications, 2 times this and this and this is 3 more, that's a total of 6 multiplications. Just make sure they all get multiplied and line up like terms as you do it. So, x times x squared makes x cubed. X times x makes plus x squared. X times 1 makes plus x. Positive 2 times x squared is positive 2x squared. Positive 2 times x is positive 2x. Positive 2 times positive 1 is positive 2. X cubed, x squared, x's. Constant. And this is 1x squared and this is 1x, and we're adding together. Keep that in mind. X cubed plus nothing is x cubed. 1x squared plus 2x squared is 3x squared. 1x plus 2x is 3x. 2 plus nothing is 2. And there's the product. Evaluate x squared times x minus y minus the absolute value of x minus y if x equals 2 and y equals 6. For me, I like to do these in pieces. X squared is one of the things. X minus y is the other thing happening in this problem. So, if I were to construct these pieces over here, x squared is going to equal 2 squared, so x squared is equal to 4, because x equals 2. X squared means to square x. X squared equals 4. This is a fact, and anytime you know something equals something, you can substitute. So I know x squared equals 4, I can put a 4 right there. I also know if I do x minus y, that means 2 minus 6. So x minus y's value is negative 4, so I know for a fact what x minus y equals. So anywhere I see x minus y, I can put negative 4. So with those two facts in my possession, this is x squared, which is 4, being multiplied by x minus y, which equals negative 4, which is being subtracted by the absolute value of x minus y, which equals negative 4. So I take this complicated looking algebraic expression, replace one object, one object, one object, and I got this really simple numerical expression to deal with. This is a product, this is an absolute value. Absolute value officially is supposed to be done first. The absolute value of negative 4 is positive 4. The minus sign occurs after the absolute value bars occur. I've dealt with this. This product, 4 times negative 4 is negative 16. And then once I get to here, negative 16 minus 4, they're the same sign, so I add, and negative 16, negative is bigger, or sorry, 16 is bigger than negative, so the answer is negative. That's the easiest way to do that problem. If you wanted to just substitute each number in, 2 squared times 2 minus 6 minus the absolute value, 2 minus 6 to work it out, that's fine. I find it a lot easier to figure out these two pieces put those final pieces in, just get yourself to a really basic expression there. It's a lot easier to evaluate. Number 15, find the surface area. Keep in mind surface area formula, which is on your formula sheet. In case you forget it, it will be in your possession, but it's 2b plus ph. B and P come from the base of this, and the base is this triangle right here. I did not give you this side, but since these two pieces are equal, these two pieces are equal, that's going to be probably a similar idea on the test. So looking at the base only, that's where I'm going to get B from. B is the area of the base, it's a triangle. Area of a triangle is 1/2 times the base of the triangle times the height of the triangle. The base of the triangle starts here and goes all the way to here, which is a total of 16. The height is perpendicular height, so it's going to be this 6. 1/2 of 16 is 8 times 6 is 48. The perimeter of this triangle is going to be the sum of the three sides. This side is 10, this side is 10, this side is 16. 10 plus 10 is 20 plus 16 is 36. And then the height, if you can visualize that there's this triangle back here, doing sort of like that, that the height is how far apart those bases are. That'd be this measure here, so the height of this whole thing is 5. So I got the area of the base, the perimeter of the base, the height, and the area of the base goes there, the perimeter goes there, the height goes there. So if I just apply the surface area formula, I'm going to get 2 times 48 plus 36 times 5. 2 times 48 is 96. 36 times 5 is 180. Add those up, I get 276 inches squared. Alright. Triangular prism on the test would be obviously different dimensions, but it'll be of similar difficulty as that. So again, it's just specific application of the surface area formula. Area of the base, perimeter of the base, height, find those first, substitute the values into the equation, and work it out.